Welcome to JCon! Welcome to JCon. Thank you for joining our keynote. Great that you are all be here. And I am super excited to do this keynote together with Mark today. And when I was at the first time at a Java conference, almost 15 years ago, so at Java 1, and then saw all these great speakers, a lot of participants, then my dream was to build something, an open source product or a free product. So open source was not the popular 15 years ago, it was the starting of open source. And my dream was to build something where I can give back to the Java community with my team, something that is valuable. And this keynote is about EclipseStore, which is now, very proud of that, an Eclipse project, an Eclipse open source project. We worked on this project for more than 10 years, and it's in production use since 8 years, and we open sourced it, and it's now an Eclipse project. And this talk is about how this works in the functional principle works, what the value is for the Java community, and how this works together with the JVM, with WebSphere Liberty InstantOn. So the promise of this project is really huge, and I know this is really tough because of we say that you can get 1000x faster data processing with Java, and you can save more than 90% of database costs in the cloud, and it's even more simple to implement. And we worked on, when I started with my team working on Java, then we started with a Java development environment. It's called Rapid Eclipse. We have a booth outside about this project. And this is a kind of like Visual Basic for Java. And the problem we had was database programming, because we built 3 GUI builders, thanks to some microsystems, Swing, JavaFX, and then Vaadin. 3 GUI builders. This was not that challenging for us. Database programming was, because the GUI builder works like a graphics program. It's super easy to use, but database programming with JPA was always too complicated for our users. So when we tried to make it more simple, then it was slower. When we tried to make it faster, it was more complicated. So we tried to find something different. And then we recognized there is a functional principle called system prevalence. And I'd like to talk about this in some minutes. So the basic problem, the fundamental problem was Java, and all databases on the market are incompatible from a technical perspective. And this is a big challenge for us in all projects. And here I can see an architecture of a simple Java application. Everything is object-oriented, everything is fine. As soon as we want to store data, we obviously use relational database. But it's incompatible because relational data model is completely different. And we have some mismatches here. So subtypes are not supported. We have different data types and so on. we have a mapping in between. So this is the reason why we have to develop our application around the database. But we are used to use it, so it's common, because the databases were there before Java came up. So you can read about the challenges in the internet. You find a lot of articles. What's about NoSQL databases? Many people think EclipseStore is kind of like NoSQL database, but we have the same issues here as well, because all these NoSQL databases, they introduce a new data structure, like a column store, JSON-based or key value, a graph. But all of these data structures are database-specific data structures, and they are all incompatible with the Java object model. So we have kind of like data, a mapping or a data conversion in between as well through every single read and write. And this is very expensive. But of course, the issue is solved because we have Hibernate. We have also an Eclipse project for that, Eclipse Link. And so the problem basically is solved, obviously. But we recognized when we used it in our development environment that it becomes really slow. So queries are slow because of this object relational mapping through every single read and write. And even if you retrieve data from a hot cache, the object has to be converted. So we have these delays as well. But no problem, you can add a cache. So it's common to use a local cache. Then you can retrieve data directly from cache, should be faster. That's great. But we always talk about microservices, distributed systems. If you run a distributed system and a user changes data on one node, that's fine. The node stores data in a database. The database and the node are in sync. That's great. The problem is all the other nodes are not in sync with the database. What you're going to do is the problem is solved. Yeah, there is another cache strategy. So just put your cache in between the application and the database. Of course, we want to avoid a single point of failure, so we run a distributed cache. We run a cache cluster. And we call it in-memory computing. And it's in memory because the data is kept in memory in a cache, but the cache is not in the same application instance. It runs on a dedicated machine. So we have wire in between. So actually, this is not in memory. And in-memory databases work the same way. They are in memory, but you have to get access via wire. So this is not in-memory performance. This is wire performance. So, and if you have more load on a database, you obviously need a database cluster. So we have 3 clusters running just to store data. And when we talk about microservices, we have multiple instances, or we have multiple services, and we have a lot of instances of our service. So it becomes more and more complex. And when we talk about cloud computing and microservices, mostly we have a look on the services itself, and the DevOps, they will tell you, please use small machines, please avoid big memory machines because memory is so expensive. Okay, we have to save money in the cloud, of course. So best would be use lambdas, small memory, stateless. When we have a look behind the surface, so what happens a little bit deeper, then we can see we use to store data, we use monolithic database servers with a lot of memory inside, because you need a lot of memory to run a powerful database. Stateful machines, and it's the same with distributed caches. So data they have to be stateful. For distributed cache, obviously use a lot of memory. So actually we do not what the DevOps say, so we actually use a lot of memories, a lot of machines, and so this is the reason why the cloud costs are skyrocketing. And this is not enough because you cannot query a cache. So many people use search servers. So more and more solutions just to store data. That's crazy. And then the cost. For instance, if you use a PostgreSQL as a service, 250 gigabyte, small machine costs you around $8,000 probably per year. Probably you will find a cheaper solution, smaller machine. Probably you find a machine for $5,000. Then if you need a replication, then your price will double, triple. So it's very expensive in the cloud. And we talk about PostgreSQL, no license fees. The cloud providers provide us cloud object storage, super interesting. And 250 gigabyte, for instance, at AWS S3 cost only $70 per year. And they provide uptime, data center replication, everything included. So it's only $70. So there are great solutions already. And there are some facts about Java, because Java is super fast. When we talk about the performance of the JVM, everything is executed in microseconds in memory. So in-memory computing with Java is extremely fast. And we have a great data structure. We have the best data structure because we have objects. We can store single values, we can deal with lists, we can use collections, we can build complex graph structure, and now we can deal with vectors. It's not a problem in Java. The databases are limited, so they provide you only one data structure. They can deal only with one data model, and this is the reason why they are limited for a use case. So a vector database is specially built for vector search. A graph database is for complex data, and a time series database is suited for sensor data, for instance. So you have to make a decision. With Java, you don't have to make a decision, so we can deal with everything. And we have a great query language, Java Streams API. And with Java Streams, you can search in memory. Let's assume you have a 1 terabyte memory machine. You have a really complex data structure in memory. You can search it in microseconds. In microseconds. A database response time is milliseconds. So with database performance, we talk always about milliseconds. It can't be faster, even if you have a in-memory database. Why? It's because there is object relation mapping in between. It takes milliseconds. And there is a functional principle, and this is not our invention. This was used by online banks or gaming companies for more than 10 years or even longer in practice, and it works great. So how can banks build a high-frequency trading application that provides a response time in microseconds? How is this possible? Do they use a traditional database that provides only milliseconds response time? No. They mostly build a huge monolithic application. Everything is in memory, and they use a programming language to process data. So I cannot talk about the project, but there are famous banks on the market that provide such high-frequency trading applications, run big monolithic Java applications. The application is built with pure Java, and they reach microsecond response time. It's awesome. And also gaming companies who have millions of players playing a video game at the same time. The problem is they have to build an in-memory database for their own, for only one application. And this is super effortful and expensive. For a bank, this is okay because they make 100 million or even $1 billion revenue with their application, but it's not suited for a business application. But with EclipseStore, now we build a solution. You can use it from scratch. We have a framework for that, and you don't have to care for all of these features in behind. So you can now use it to build such powerful applications with pure Java. The functional principle is called system prevalence. It's a simple concept, actually. So keep data in memory, use your programming language, and everything is fast and fine and simple because the architecture is simple. It sounds too easy, and it is too easy because there are a lot of challenges. Because what happens if my classes change? What about concurrency handling? What about user management, blah, blah, blah. So you have to build everything for your own. With EclipseStore, you don't have to build this for your own because the framework manages all of this, similar to a database management system, but it's not a database management system. It's just a storage layer. It's just a persistence layer. And the rest, the business logic, the Java application cares for the rest. Because we do it for ourselves anyway. User management, concurrency management, logging, locking, everything. What I saw the last 20 years, user applications, it's built by Java developers because we can do it better than a database, and the Java standard do not care for all these database-specific features like stored procedures, stored functions. It's ignored by the JPA standard, so we don't use it anyway. The only thing we are not using in Java is persistence. This is the only thing, the only missing feature. And this is what EclipseStore provides. So in a nutshell, this is a micro persistence layer. We call it micro because micro is simply fancy term. It's small. It works with microservices. It's easy to implement, so micro persistence layer. And it enables you to store any object model. So build whatever you like in Java. And we can store it persistently into any data storage. We store it in a binary format and we serialize the objects to disk. But we do not use the Java serializer because it is insecure, it is slow, it cannot deal with complex object structure, it cannot store your object graph partially. So we built a serialization framework from scratch. It's now also an Eclipse project. It's called Eclipse Serializer. And there are a lot of serialized frameworks on the market. We didn't use them. It's because of they have all the same problems like the Java serialization, and they all do not cover like schema migration or complex object structure. This is the reason why we developed Eclipse Serializer. So now you can build whatever you like in Java, can persist it, and we can load it at any time into the memory and restore the object graph in memory. And we also provide lazy loading, which means you don't have to load the whole database in the memory. You can run it even with lambdas. So even with only 512 megabyte, this will work, even if you have a terabyte database. The more memory you have, the better it is, of course. So the architecture is simple. So we replace object relation mapping or data conversion for a NoSQL database with EclipseStore. We don't need a cache anymore because we keep data memory, we have the object graph in memory. This is already our cache, so we can skip all the complexity with cache configuration also. And we don't need a database, we just need a hard disk drive. Or you can use a blob store because it's fully managed. So it's recommended to use a blob store, but it's not mandatory. Just can use plain files. This is the fastest way, the fastest I/O operation performance. It's almost as fast as your hard disk drive will be. But we had a lot of challenges. So we solved all these challenges on a single JVM machine. And then the last 4 or 5 years, a lot of people ask, okay, what about distributed applications? Sorry for that, but we didn't cover distributed applications. You can do it for your own. It's an open source project. Elastic scaling also. So, but the last years, more and more people ask, and they told us this is mandatory. I mean, we are in the cloud, so we have to scale horizontally, and we want to have serverless So what does this mean? If you have an application and the load goes up, then your application obviously is in trouble. So we like to scale out our system, start some more new processes to scale horizontally. And if the load goes down, of course, we want to scale in our application, shut down the nodes to save money in the cloud. And everything should be done automatically, fully automated. This was our goal. If the load goes up, vice versa, system should scale out again. So how can we achieve that? So we worked for 2 or 3 years on this concept, and we had some challenges because some challenges were because of the architecture of EclipseStore itself. So the startup time of EclipseStore was really too long, and then we had challenges that also the JVM startup time was too long. So in addition to the startup time of EclipseStore, we had startup times between 12 seconds to 15 minutes. JVM startup time was in seconds, and EclipseStore issues were startup time up to 10 minutes or even longer. So this is not suited for a highly scalable system in the cloud, no elastic scaling. This was really a big problem for us. So our first approach was we have to build, don't care for startup time, let's build a solution that is able to distribute the memory state through multiple JVM instances just to provide a cluster. So a static cluster. We were able to do that in 2 years. Now this system works. We can now provide a distributed EclipseStore application that scales horizontally. It provides horizontally scaling. It provides eventual consistency approach. We do not care for fully consistency in the cluster. So it's because of full consistency is very difficult. And it's always different. So we focused on eventual consistency. Static cluster is great. So you can now define how many nodes you want to run. And you start your cluster and then you're good to go. But it cannot scale. But it's a great benefit for us, for our users, because now we can provide distributed applications. And then we were working on a pre-scaling system. And the concept sounds simple. So the system should collect data and should decide when a new node is required and start a node in at once. So, but you have to make a lot of expectations. And it's very hard to build such a system because maybe your expectations are wrong, and then you pre-start a node and it's not needed, or actually your cluster needs 3 nodes and you only start 1 node because your expectation was wrong. So this was not really a good solution. Then we heard from GraalVM native images, and we thought this is absolutely great. This is a game changer, and in my opinion, this was really a game changer for Java in general, to be fast enough to build microservices, serverless applications in the cloud, and to destroy all these discussions about, is Java fast enough in the cloud, or is Python better, or .NET or something like that. So absolutely game changer. When we tried to use it in our cluster solution, then we recognized it's doable and we can do that. So because we are experienced, in my team we have experienced developers, but all of our users, they all have to deal with GraalVM native images, and there are some trade-offs, and we believe this is too complicated for most of our users. So to tell them you have to use GraalVM native images in all of your applications, in any case, was not the solution for us. And then we recognized there is a solution on the market with WebSphere Liberty InstantOn. It's a completely different approach, and this is a great approach that worked for us. And the solution is interesting for us because we're Eclipse project, and the Eclipse Foundation is known for a development IDE. But there are a lot of projects in the Eclipse Foundation, more than 100 open source projects, and most people, of course, know Jakarta EE, Microprofile, but also there are a lot of interesting projects like the OpenJ9 JVM, and we have an OpenJDK, and we want to build a solution that uses Eclipse projects. And how this works, Mark will tell you now how this works and how this fits together with EclipseStore. I'd like to hand over to Mark.
Thank you, Markus. Risky keynote process number 1, step over all the cables. Risky step number 2, switch the laptops, including the HDMI. There. Okay, so I'm going to talk in this keynote more about WebSphere Liberty InstantOn, which is a capability, as Markus said, which is designed to provide really, really fast startup for Java applications. Turn on the clicker. Risky step number 3. Okay, avoid the clicker. All right, just a little about me. It feels like 25 years sometimes, but it's really only been 22 years that I've been doing this, building Java runtimes at IBM. So I've worked my way up at IBM, so I'm now the chief architect for Java at IBM. But I also am a project lead, and I was the IBM technical lead responsible for open sourcing the OpenJ9 JVM, as well as the OMR project, which also came from IBM. And I was also the architect for the creation of the IBM Semera runtime. So I've been involved in Java at IBM and all the things that we do, both in open source and for our product stack, for quite a long time. Open Liberty, WebSphere Open Liberty, if you haven't heard of it before, is a very lightweight modular framework for building Java applications. Some people, when they hear the word WebSphere, they think the big, complicated, full-featured, that's the IBM term for it, full-featured, large-scale, can do anything that you need it to do, and it's all in one big piece, but it tends to be slow to start up, and it tended to use lots of memory. Liberty is a redesign of that, which is great for all kinds of more efficient uses. It's modular design, so if you don't need a feature, you don't have to load a feature. That means it can start up a lot more quickly, and it uses a lot less memory, and it's just an overall great development environment for new Java applications, and also for migration target. Now, recently we've been augmenting Liberty with a feature called InstantOn, which is trying to provide very fast startup, leveraging a library that's available at the Linux level, which is called CRIU, Checkpoint Restore in User Space is what that stands for. That's a library that's been around for more than a decade now. And it's basically, it's able to checkpoint a Linux process. You can take a running Linux process, essentially save it to disk, and then later on you can restore that process from disk and start running the process again. And we're going to use it for a very specific process, the JVM process. So we've designed this primarily for use in Liberty container deployments, so it works really well with containers and on Kubernetes. It's designed to start applications in milliseconds because that's how fast restoring a process can be, and which makes it ideal for serverless applications and what Markus needs in the EclipseStore world. Finally, one of the goals that we had for developing this was to make it really, really, really easy, because CRIU is a great library. It can do a lot of things, but it's kind of complicated to get it working properly. So we wanted to take care of all that complexity, shield users from it, especially at the Java level, and make it really easy to use. So at the bottom left there, you can see sort of the basic flow for how we expect this to work in your usual environment. You're developing applications. In your build step, your CI system, you're going to start your application, and then you're going to take a checkpoint. You start it up. Before it accepts any load, you're going to start a checkpoint. You're going to create a checkpoint. That checkpoint gets added to the container that you're building, and then you can ship that container off to wherever you're going to deploy it in production, and you do a restore, and that restore is just going to pop back up and start running your application and handle load at that point. As you can see, we have some measurements on the top right there, which give you a flavor of the kind of performance improvements you can get for startup for a variety of kind of EE and not quite EE level applications. You can see the bars on the right are even hard to see on each of these graphs because they're so fast. That's basically in the 100 millisecond to 200 millisecond range for these applications. And that has a great impact. The lower set of graphs is on first response time. So obviously starting a server is great, but handling load is what you're really there for. So getting to the point of being able to handle that first transaction much more quickly than you can before, could before. Now on bottom right, we've looked at a couple of different options, and one of the reasons why we haven't also looked into the Graal native space more deeply are the same kinds of reasons that Markus mentioned earlier. So full Java support is important to us. We've been a devout member of the Java community for over 25 years. I guess it's coming up on 30 years soon, isn't it? So we believe very heavily in the Java standards and making sure that the things that we build are standardized so that everyone can use them regardless of what they're running. They can count on those standards being there. In terms of getting instant-on performance, yes, Graal can provide instant-on performance. In fact, probably even better. I'll even take away the probability. The probable native image will be a faster startup solution, but not very much faster. In terms of throughput, though, there are some issues here because, as Markus mentioned, there's no JIT at runtime. So if there are changes in load, you can't react to them in a native image. The memory use is usually pretty good for most, but the other problem here is dev-prod parity, which is you want to be using the same thing in development that you're using in production, and very few people recommend using native images as part of your development process. Mostly you develop on a JVM and then you ship on a native image, and that's a very different kind of environment to work with. All right, so I'm going to go through very quickly just how this stuff all stacks together. And at the very bottom of the stack, as I mentioned before, is the CRIU library that's provided at the sort of Linux level. It runs in user space, obviously it's in the name, but it basically just allows you to checkpoint that Linux process and bring it back later on. Now above that, in the Eclipse OpenJ9 JVM, we've implemented a layer of support on top of CRIU, which provides some facilities for Java programs and the JDK itself to be able to register things that need to be updated when you restore in a different environment. And I'll talk a little bit more about some of the challenges that we have with trying to bring a snapshot back in an environment that wasn't the same one as it was created in. But there are some examples here, like updating some dates and times. Like the greatest example is if you checkpointed the start of the server in your build environment, and then you days, weeks, months later start one of these, restore one of these processes, do you want the server uptime to reflect all the time that it stayed on disk sitting in a container until you deployed it? Probably not. You'd probably prefer to be catching uptime from the time that the process was restored. And so there are a number of these kinds of things that both Eclipse OpenJ9 deals with itself, as well as provides facilities for the layers on top to build on. And so Semru JDK is open. Eclipse OpenJ9 is a source project, so it doesn't actually produce anything. Semru Runtimes is the JDK that produces the binary distribution, so it builds OpenJ9 and makes it available for people to use. Actually, maybe I'll pause here for a sec. How many people here have heard of Eclipse OpenJ9? Okay, that's not bad. Maybe 25% of the audience, I would say. How many people here are using Semru Runtimes or OpenJ9? Ooh, that's a smaller group. All right, you guys are great. Hopefully I can convert more of you with the results that we're going to show here. Right, so Semru Runtimes on top of that. Liberty, so the Liberty, we've done a lot of work inside the Liberty app server to leverage the facilities that Semru Runtimes and Eclipse OpenJ9 are providing via Linux CRIU to make sure that the pieces that the Liberty runtime are creating are managed through this checkpoint restore process and that they're appropriately updated. And the reason why this works really well is because Liberty knows more about what it's trying to achieve when it's creating various resources, and it knows what should be done to handle those resources across the checkpoint. Finally, there's the user application, and which builds on top of the Liberty app server. And that one actually doesn't even need to be aware of the fact that a checkpoint and a restore is happening. There are situations where you will need to know, but you don't have to know because of the way that we built this. All right, so let's talk a little bit more about this challenge of restoring an application in a different environment than it was created, i.e., picking it up from your build environment, creating a checkpoint, and then restoring it in a production container somewhere on the cloud or wherever. There are lots of pieces of the JVM that need to get updated, like the time objects that I mentioned before. There are other things like the number of CPUs might be different, and you need to accommodate for that. So, for example, on your build machine, it might be a big, powerful 64-core or more core massive machine. You don't want that checkpointed process waking up in a 1-core container on the cloud and start 64 GC threads or 64 JIT threads and totally just smash everything out. You also want to be aware of what the resource limits are. Your build machine probably has lots of memory. Your running container may not. So you need to adjust the heap size, figure out all of those kinds of things. And then obviously there are some things that you're on a different host, so the host name is different, and the environment variables might be set up differently. And in fact, that's quite important because you may actually want to pass command line options into this this restored process, but you're not actually invoking the process, which is where the command line processing usually happens. So there needs to be a way to inject new command line options, and obviously locales could be different, but hopefully not. There's another aspect to this which is interesting, which is sometimes you really, really need the restored processes to be unique, even though the checkpoint is you're trying to ship the same checkpoint everywhere. And a great example of this is random number streams. If you allocate the seed for a random number stream in the checkpoint, every process every restored process is going to use that same seed, and so a random number stream that's supposed to be random is actually going to be identical on every single one, and that's probably a bad thing. Sometimes it's a good thing, especially in serviceability situations where you're trying to reproduce something that actually happened at runtime in one particular run, but most of the time it's a bad idea. And then there are other aspects like security, like you don't want your keys stored inside the checkpointed process for everybody to download and review. So there's lots of these kinds of things that Liberty kind of takes care of. And there are lots of scenarios where we specifically do something different if we know that we're going to be checkpointed than what we would do if we were just running normally. So we defer some things during Liberty startup so that we don't have to worry about checkpointing them and restoring them later. So the last question, now we know all the problems associated with taking a checkpoint, is where do we take a checkpoint? That's a big open question. And so this is actually one of the areas where Liberty gets very opinionated. It provides exactly 2 options for where to checkpoint. Well, I guess technically 3. I promise this isn't a Monty Python skit. But, okay, so you could not checkpoint. And then the other 2 are you could checkpoint before any of the application code is started up as part of the initialization of the server, or after those applications have been initialized, but before load has been applied. So there are no socket connections, there's no network activity here that's being exercised, etc. But these are the two basic options. And as you can see with the green and the red arrows, there's some trade-offs here in which ones you pick. Obviously, we'll start with the green arrow. The later that you checkpoint, the less has to happen after you restore, and therefore the faster your startup is going to be in the restored process. And that's generally a good thing, so you want to checkpoint as late as possible. But the red arrow is talking about the complexity of being able to restore a checkpoint that you've pushed off as late as possible. And that's because the code that runs in that start application bit there might be application code. We don't know what your code is doing. You could be doing all kinds of crazy things in there and storing all kinds of resources that aren't necessarily being, using the appropriate resource or appropriate facilities to make sure that they get restored correctly. So if you're not handling that stuff, then restoring that checkpoint is going to be a bad idea because there's things that are just not going to work properly. So it's more risky to use the later time. So we want to checkpoint as late as possible, but we don't want to manage too much risk, so we want to checkpoint early as possible. Basically, the before app start checkpoint is always safe because it's only the Liberty code and the JDK code that has been checkpointed at that point, and we know everything about what we're doing. So we've managed that. If your applications don't do anything risky, then you can also use the after app start. All right, so who wants to see a demo? Risky keynote number 4. So I've been having a lot of trouble with my laptop today, or in the last, see, even this didn't come back properly. Let me see if I can get all of these windows back. That's not the one I want. What is going on here? It resized everything. That's wonderful. Okay. Normally when I do this demo, I will build the containers from scratch, show everybody that I'm not, holding one hand behind my back while I do the demo. Given all the trouble that I've had with internet and container registries refusing to download things for me, I'm just going to run them from my laptop, and I'll ask you to trust me that I'm not showing you something that's not really there. So I'm going to repeat one of the exercises that I had in my workshop yesterday. Just because I have it up and running, and that's a little bit safer. So what we're going to do here is we're going to start a container with Open Liberty first, and with I'm going to start it with Temurin. So Liberty is JVM agnostic; it can use whichever JDK you want. So I'm going to start it with Temurin, which is the Eclipse Temurin community-built OpenJDK binaries. They're quite popular. Lots of people are using them. Who's using Eclipse Temurin? Yeah, that's more than OpenJ9. All right. It's about half, maybe. Okay. So what I'm going to do is I'm going to start a Liberty workload. It's called it's our getting started guide. So it loads a few features. It's not quite as simple as a hello world. So it does load a number of features into Liberty, and so there is some substantial startup activity that's going on there. And we're going to see how long this takes. Let me see. There we go. So let's just run it. So there's nothing on the screen. No. See, it ain't so. Well, that's going to impact my demo. Let me see if I can make it work and show. Let's bring it back. Wow. All right. So I have another. It's over there. Okay. All right. Let's see if I can. Whoa. Risky keynote move number 5. It's also very slow over there. Okay. It worked. I want it over here. All right. Sorry. There's another window I need before I can continue here. It's this guy. Zoom. Wow. Okay. The keynote may run long today. Little extra activity here. So I have Podman stats running in the top there. And you can see in this window, I've started Temurin. I can't actually show you with the mouse because it's too hard to do it. But you can see at the very bottom there, the server started in 4.952 seconds, so just under 5 seconds. And if you look up there, it's using 190 megs of memory. So because the demo uses the same names for everything and the same ports. Uh-oh, that didn't work. What just happened? Go Mac. All right. So I'm going to stop that. I'm going to try to stop that. There we go. And then I need my window back here. Okay. Bear with me. So this, what I'm going to start now is I'm going to start Liberty using its default Semru runtimes JVM. And this is not going to use InstantOn, but it's going to, it does have a shared class cache in it, which allows it to start a little bit faster than the Temarin one. So let's just get that one going in the interest of time after I learn how to type. That's going to blast by. So that's 2.85 seconds. So that's remarkably faster. It's maybe, I don't know, 40%-ish faster. And it's using 96 megs of memory. So it saved quite a lot of memory by default. Now, I'm not being too aggressive on tuning for heap size. Obviously, you could reduce the heap size for Temarin, and it would probably use less memory. But if you give as much memory as you think you're ever going to need, basically the Semru runtimes is able to kind of keep the memory down, whereas Temarin doesn't focus on that particular problem. Now, I need to kill this one so that I can show you the InstantOn one. And for that, I'll just use this window. I believe it's 4. Okay. So, right. So let's just first look at this Docker file. So, it's going to be hard to... So a lot of this stuff is boilerplate. You don't have to worry about it. It looks quite dangerous. But the top here, so we're starting from a default Open Liberty container that's available for anyone to use on the IBM container registry. And then the key bits here are, so every time you deploy an app with Liberty in a container like this, you run a thing called features.sh, which configures the exact features that your application needs. That's part of the lightweight nature of Liberty. So if you don't need something, it's not loaded into the server. There's also this configure script, which is the thing that takes care of configuring the JDK as well as a few other things and creating a default shared class cache, which is the thing that provided the benefit in terms of startup time for Semru runtimes in the previous run that we showed. And then finally, the bit that I've added for creating this checkpoint is this one command, checkpoint.sh. And then I'm going to do the after app start because I know that this application doesn't do anything dangerous, and so I want as much startup as I can because it's a keynote and I have to look good. We ran it yesterday in the workshop, and it's about half as fast the before app start, so it's not that different. Okay, so we had that Docker file. I've already built this, so I'm not going to rebuild it. In terms of running, it's a little bit more complicated to run. I didn't actually show you the command line, but it didn't have a lot of this stuff. It was just kind of load the container and run it. In this particular case now, we need to help the container get the right capabilities to be able to use the CRIU library. And that means starting the container with checkpoint restore and set pcap. One thing I want to point out here is that you don't have to open up the security capabilities, so there's no security impact here. And although I am running as root, you don't have to. It's just easier in my setup here because I'm running a container inside a container. I'm running all this on my MacBook, by the way, but these are Linux containers. You do need a modern Linux kernel to be able to do this properly, or have it work the best. But and I'm running all these in one core as well, just to be up front. So then let's do run.sh. Okay, let's learn how to type. You'd be amazed how many times I have to do that joke. And it comes out pretty fast. 0.218 seconds. So 218 milliseconds. I'll just say that wasn't a fluke. Poof. 212. I have seen it start in less than 0.2, but I'll do one more risky keynote move, the third time. Yeah, 227 got slower. Oh well. But it gives you a flavor for the variation you're getting. So you're getting a startup of a full Liberty server. You can see all the features that are listed here, right? This is not just a little hello world kind of example. It's loading some substantial features into the Liberty server, and it's able to start all of that in 0.227 seconds. Well, let's see if I can make this work. I was gonna do this. Oh, more mouse maneuvers on the screen. All right, I just have to get it up here so that I can see. All right, where is it? Where is it? Started in, there we go, 4.952. Can't read my own screen here because it's so bad. 4.952 divided by, what did we get to? 0.227, right? That was the slowest one. 21.8. So that's, I like doing this because it's fun. Blammo, that's a big number, right? Probably a little bit more precision than we need. All right. So basically, if you're starting a server like Liberty with a JDK that's not doing instant-on, you're leaving a lot on the table in terms of startup time for your applications, and that means you have consequences in terms of responsiveness and your ability to be elastic as you're running. Now, I do have, okay, risky move number 5, I think I'm at. I have to get my presentation going again, which I of course minimized in order to get it to do this over here. Okay, let's try that. Wonder if my clicker works now. I'm not going to try. So just to give you an idea of where this all works, so it works on all the platforms that IBM cares about, mostly on Kubernetes. These are Kubernetes platform supports. I'm actually running it on my Mac M1, so clearly it runs on ARM64, but we don't have all the support on Kubernetes on ARM64 that we're looking for yet, so we don't have it in the list. It's been tested and supported on OCP 414, as well as EKS and AKS, so it will work out of the box on those clouds. They use modern enough hosts in order to be able to support the level of CRIU that makes this work really easily. It might work on other clouds, we haven't tried everywhere, as long as the hosts are being deployed with a modern enough kernel that's level version 5.9 or above. And you also have to have the ability to specify those Linux caps that you need in order to do checkpoint restore. And as you can see in the deployment YAML, it's very easy to do this, right? You just have to add those 2 caps. And you do not have to run as root. You can run as non-root. I always hate the name of that one because it's kind of like a double negative. Run as non-root is true, and privileged is false. So you don't have to add any wicked security openings in order to get this working and running in practice. And finally, in terms of Liberty features, so not all of Liberty can support it yet, but a lot of the important stuff does, right? So Jakarta EE8 and up web profile, microprofile versions 4.1 and up, as well as all of these other features that are listed here, which are things that people commonly use. And so if you accidentally have a deployment where it tries to use a feature that does not support instant-on, then it will fail when you try to create the checkpoint. So it will fail in your build environment, and it won't fail at runtime. You will find out about it in time to fix it before it brings down anything that you're running. And obviously, if you do that and you find a feature that doesn't support it and you want it, please talk to us so that we can do the work that's needed in order to support that for you. Finally, we have a beta that's going on right now for instant-on that can run Spring Boot applications. So you can run a Spring Boot application on top of Liberty. And right now we have a beta that's been there since the end of last year that allows you to do instant-on with a Spring Boot app running on top of Liberty. So you can get this fast startup for a Spring Boot app. And with that, I'm going to pass it back to Markus. Risky keynote move number 6, I think. Oh, no? Nope, we're done?
Actually, there are some questions.
Oh, we had questions.
No. Thank you.
What a novel concept.
Yeah. Okay, so there are 2 questions about EclipseStore. So how the framework handles class updates, so schema migration. So we have a concept that's called legacy type mapping, and if your classes change, then it's mostly solved by the framework itself through runtime. So the framework loads an object into memory and compares the object structure with your class. And if there are changes in your class, then the framework can solve this automatically. If there's, in the easy cases like you add a field, you remove a field, rename a field, change a primitive type, this can be solved by the framework. And for more complicated cases, you can define a so-called legacy type mapping and can define that. And when you store your object again, then you have two versions of your object in a storage, and then you can define whether the garbage collector of the EclipseStore framework, which works on file base, should remove the older objects or keep it in the storage. So it's your decision. Second question was, these are InstantOn questions. Storing an object, if this is not too slow, storing objects into in a storage is very fast, because I/O operations are almost as fast as your hard disk, so it's super fast. And we also provide channels, so the more cores your infrastructure provides, the more channels it can be used, and you can have parallel input-output operations. And loading objects in the memory and restoring objects in memory is also fast. I mean, it's physics, so it can be faster than your hard disk drive or your bus system, of course, of your architecture. But we have lazy loading, which means only the lazy references are loaded and restored in memory. So you as a developer can define whether you want to have eager loading or lazy loading, and if you decide for eager loading, then your objects will be preloaded, and if your object references are defined as lazy, then the framework only loads the object reference when you touch the object. And you just have to call get methods, so there are no more classic selects. Just call get methods, and then your object reference is loaded in the memory and restored in the memory, and it's automatically merged in your object graph. So you don't have to deal with object copies.